Hey folks, how you doing today? We're back and we're looking at something new from Espressif. This is the ESP32 P4. It's a relatively new SoC or MCU that just came out, and this is their evaluation board for it. So what's cool about the P4 is it's added custom extensions for basically DSP, digital signal processing, and AI, so vector multiplication, and they're built into the RISC-V cores that this has. So I thought I'd order this Eval Board or Dev Board. Got it from AliExpress. It seems to be legit. I couldn't find it anywhere else because they are very new and high in demand. And I thought today we would give it a go. So first off, we want to have a look at what it is. Now, if we go over to my newly defined board taxonomies, where are we here? We'll get back to that one. We've got embedded board taxonomies here, and this is something I've been working on for the last couple of weeks or even months and talking to others about. But we all know what an SBC is. We've got a single board computer, but what I'm saying here is it runs Linux and it's got HDMI. It is a computer, it's just small. That's that. Everything's on one board. You've got the slight variation, which is a compute module. So you got the board itself, like the Raspberry Pi CM1s and whatnot, and then you've got the board it goes onto. So we've got some examples there. We've then got an ESBC, an embedded SBC. So that's where it still runs a full Linux, has MMU and everything, but there's just no graphical interface. So you're gonna have to SSH your UART to it. You get a few different form factors there, and there's quite a few examples, but then you get slightly smaller. So let's just say it's basically an ESBC, but it doesn't actually have an MMU. So it might run a weird variation of Linux, but it's really meant for Arduino, MicroPython, CircuitPython even, or an RTOS. That I'm calling an embedded system board. So that's got an MCU or an SoC. It's meant for embedded systems. Raspberry Pi Pico, some of the Arduino boards, ESP32 development boards. Actually, I've got to fix that up because there is one more definition now, which is the dev board / eval board. So that's where it's not designed to be an embedded system board. It's a proof of concept for an SoC or an MCU. So just like this one we've got here, what we're really looking at is the ESP32 P4. This is the evaluation board that is meant to show off all of the features of that. So typically these are a bigger form factor. They include with manufacturer specific tools and documentation. They expose nearly everything that the SoC or MCU is supposed to do. And they might even come with like a debugging connector or something like that. So they're meant for people or companies that want to see what the chip can do to really give it a shot. And that's what we're going to use here. So let's open it up and have a look at what's inside it. Now, don't forget to like and subscribe if you enjoy this sort of stuff. It definitely helps me out because it lets YouTube know that my content isn't too shite and sends more people this way, which means I get a bit more ad revenue from it. And if it's a sponsored video, it means the sponsor gets a little bit more incentivization to incentivize me. Now, what have we got in here? We've got a nice box. We have a very non-standard form factor, as you'd expect to see from that sort of board. We have the camera interface. We've got an LCD ribbon. Is this? Ah, yep. And under here, we have a nice LCD. Excellent. This is, pretty hefty feeling LCD. We've got some connecting pins. Nice logo on there. Not bad at all. USB power. So I'm looking, it looks like you'd power in here and then that power will pipe through as well. So let's get this out of the way. Now, speaking of sponsors, this one isn't sponsored by my usual, which is PCBWay. I'm happy to say that because they are good people. This one is pretty much sponsored by me. I'm not sure if you know, but I do have an online store. So if we quickly jump back here, and we don't even need that camera, do we? And have a look at shop.platima. I might have to change this one day. No one knows what Platima means. I don't even know. I made it up 21 years ago. But I sell a lot of ESBCs, SBCs, dev boards, SoCs, MCUs, accessories, camera displays, power supplies, tools like soldering irons and everything like that. So you can see now I've just bought in some of these. I think I'm getting some of these in there on pre-order. Some of these Core 3576 and Omni 3576. I'll make a video when they come out. I've now also got the RP2350, which I had in my last video, the WaveShare Plus variant. So I'll put a link below to 5% off anything you want from the store. I do free shipping internationally on orders that are big enough, slightly less restrictions on shipping within Australia. Otherwise, the shipping is what shipping is. I don't really make money from this yet. It's just I buy these in bulk because I want to use them, get a better price, and I share it with all of you. Please do check it out if you want to support me. And if you want some of my swag, I do also have these branded rulers that I made and designed myself that are 15 or 30 centimeters in purple or matte black. But regardless, all orders also come with a little 10 centimeter variant. So I've got a very worn out version here, but I'll throw one of these in with every order, no matter what, just because they're handy and I've got hundreds of them. Now, back to this board. So let's have a look at its, actually, you know what, let's have a look at the price and availability, because this is an important point. I couldn't actually find many around, so I ended up paying about 150 bucks Australian, whatever that is in freedom dollars, less than freedom dollars now, to just get one of these from AliExpress, because why not? So I'll put a link below to whichever one I got it from, in case you want exactly the same. The price is pretty good for a dev board or an Eval board, I guess. Like, it is very full featured, so 150 bucks with maybe a little bit of shipping isn't altogether all too bad. But the availability is pretty lacking. Now, if we look at the availability of just this chip, it is very, very new. These chips take probably 5 years to design, and then after they're designed and released, I'm going to say 3 to 5 years. After they're designed and released, you've probably got another, or you're looking at, I guess, a year or two before they're really in the market. And that's because it does take a while to make and design these sorts of boards. They're actually very complex. So I think we'll see more of it coming soon. And Waveshare will hopefully have theirs soon, and I intend to grab some of those, get them in my hands and try them out. For now, this is what we've got. So I'm going to say, as far as the tier list goes, 2 out of 5 stars. It's not readily available, but it's not bad priced. 2 out of 5 stars for availability. Now let's have a look at the actual features here. So form factor is pretty weird, not very standard, but it does have what looks like the standard holes there. So it would mount on a standard. No, that is not even standard, is it? Let's have a look. Forget my ruler. These, oh, it's got little feet already stuck to the bottom. That's interesting. I'm sorry if this is lagging. My preview's lagging, but I'm not sure if it's just my preview or not. All right, so we've got 55 by 48. Was that standard? It's close. Sorry, 85. What did I measure here? Yeah, no, we've got 54 by 46 roughly. So it's a bit non-standard, but so be it. On here, we've got an ESP32 C6 as the Wi-Fi module, which is quite an interesting choice. Let's fix my focus about there. Speaker connection, we have dedicated 6-pin headers there. Let's actually just pull up the the documentation here. So getting started. All right. Okay, so that's the connector for programming the C6 here. We have header, we've got our MIPI DSI connector, we've got our MIPI CSI connector, we've got SPI flash over here, the board itself. This big button is your big chunky power switch, which you cannot miss. We've got a Type A port here. Now these three have got a standard USB 2.0 Type C port. This looks like a dedicated power port, and this is a UART port using a CP2102, which is pretty awesome. Got a 10100, I believe, so there's a little PHY there. I'm not too sure what it is. And over here, we've got a boot button to flash it and a reset button. On the back, we can stick a standard SD card in, and it's got some feet on it. So, oh, that big chunky pin sticking out there, I'm not a fan of that design. So as far as connectivity goes, it's got nearly everything. There's a microphone on board there as well, so you're probably going to be able to do most of what you want. There's lots of little pins. If we have a closer look here for debugging if need be. It's not using a standard debug connection profile that I can see, but I might be wrong. You know, pardon me. You know, you get the sorts that just plug straight on. So this board doesn't have a GPU or VPU because these are designed for embedded systems. I'm assuming there's no real-time clock battery connector, so probably no real-time clock, but you'd be able to connect one with the header pins on it. And as far as encoding and decoding goes, let's have a quick look over here at the actual spec. So see if it says much about that. If we quickly fly through the getting started, this is important. Let's open that for in a minute, which way around which cable goes. Basically, if it's reversed, it's for the LCD. How to connect it. Bit of a block diagram. Let's just look up ESP32 P4 block diagram. And I saw P4 hardware encoding. H.264, full HD at 30. All right, that is really good to know. That's on that documentation there, but I have seen some amazing block diagrams for this thing. This is it here. So is this? No, that's not very high resolution. What's that one? No. All right, let's go back to this. Block diagram is looking pretty impressive. So you've got the core, dual RISC-V core, 32-bit, 400 megahertz. It's got level 2 case, JTAG, L2 ROM, L2 memory. So it's got what they call actually over here. It's got a little 40 megahertz core. So you might see it's got two clocks on it. It's got a 32K clock and a 40 megahertz clock, or a 40K clock that powers the 40 megahertz processor. And it's got low powered, this entire dedicated low power system, and that's what's called tightly coupled memory. So that is meant to be like a 0 clock cycle memory for this low core. You can JTAG straight to it. You got a little bit of ROM. You've then got, I did notice there's a battery power supply management here, along with a standard PMIC or PMU. Got a whole pile of low power accessories that can be accessed by the low power core. You then got the high power accessories, which is everything you would expect, and a lot of security modules, which is pretty awesome. So option 1 in light sleep, option 0 in light sleep, active in light sleep, optional in deep sleep, and all modes. This is a nice little block diagram. I quite like that. And of course, there's no M2 interface. It all is all kind of SD or ROM based. Now, in this, in using this, you're going to require a lot of documentation, and we're going to have a quick look through that now, because we're going to have to actually get started with setting one up. And if you go over to their GitHub, you can see here, they've got a whole pile of examples. So under Espressif ESP dev kits, you've got some of these P4 function Eval Board ones, and we're going to go for the Brooksia phone, because this will show off pretty much everything it can do. Now, the description says, it demonstrates an Android-like interface that includes many different applications. The example can utilize the board's MIPI DSI, CSI, the C6, so for Wi-Fi and Bluetooth, SD card and audio interfaces. That's what we'll be doing. That's how we're going to set it up. So first and foremost, we're going to have to get started with setting up the ESP-IDF. So, going to need to install this. And let me just grab a drink of water and my keyboard. That's better. And paste that in. Now I believe, yep, I've already got all of those. And I just did this git clone before, so we already have the ESP dev kit repo. We will need a few other things though to get the IDF fully going. So if we keep scrolling down, we've already got that. We're going to need to clone this IDF. Let's start grabbing that. And this was the repo that I just cloned before. So you can see they basically say clone it, run the menu config through their IDF, pick that from the BSP. I'm going to have to install FFmpeg, which I might already have. Actually, I have it, but I don't need it. So whilst this is installing, let's start putting this together. If we go back down here, fix our focus up, we have our display. Oh yeah, that satisfying thing. So this is a 7-inch MIPI DSI touch display. We have our Eval board. Let's grab that little bit of foam out. That'll be very handy actually. Oh, it's stuck, there we go. Put the foam down, put the display on top of it, peel off these little tags. Get off. There's got to be a better way to deal with these. I think those little tags are only on there so the automated tool can suction cup to the top of it, which makes sense for the pick and place machines. But they can be quite frustrating to get off because they don't hang over the side very much. You can also just screw straight through them sometimes, but it's not necessary. So this one, probably gonna have to put that way around. That looks about right. All right, those are connected now. So after that, we can connect the camera. We have our little ribbon interface there. This one pops out and it looks like pins are on the bottom. So you want to go that way around. Make sure that's in firmly, push it closed. There's a reset button on there too. This is our camera connector. That one is that way around. It looks like those arrows might actually indicate which way around they go. Now, what can I do with that? There isn't too much where I can stick it. We'll peel that little cover off the camera. And for the LCD, this does have the reverse strip. So this side goes that way. It should pretty much be form fit if I stop shaking so much. Yep, that is in all the way. And then this one, we didn't need that little diagram because it is all labeled. So here we have 27 and 26 going to the PWM and the, I got them slightly wrong, PWM and reset. So let's just move those pins up one to the correct. There we go. And your 5 volt and ground. And I've just screwed on with 2 of those. We don't need all of them at this point in time, so we'll get that out of the way. So as far as software images goes, they don't actually have too much, but we are going to try some of them out. We're going to try out this example one following the documentation, and we're also going to try out CircuitPython so we can benchmark it with our new little Python code that does some matrix multiplication. So that, in theory, should be set up how we want it. How is our 26%? How's that going? Not very far. So as far as software, images, and firmware go, I'm going to give it 3 out of 5 stars. The reason for that is because there is a few different versions in here in the examples. It's not really meant to just plug and play. That was meant for people to develop on. So what they have is good, and there is CircuitPython for it in alpha. This says stable release for this one, but apparently it's actually not if you go to their release notes, and they don't have a version 10 for it yet. So it's above average, or I'd maybe even give it a 4 out of 5. There's not a huge variation, but what there is good, and the fact that it shows off all of the capabilities is very, very handy. So now what we're going to do is wait for this repo to finish, and then I'm going to compile it. We'll flash it with that, and we'll try it out. In the meantime, actually, let's just try out this this CircuitPython. So if we just download the UF2, we'll stick this in our... Am I going blind? There we go. P4 folder. And let's go back to the documentation and have a look at how to actually flash it. Hardware connection, software setup, power supply, header block. All right. Getting started. Yeah, we've read through all of this. Software setup. RF menu config. Power supply options, type C, USB, USB to UART. Yeah. All right, doesn't have very much there. Let's have a quick Google. ESP32 P4 flash image. So we have to use ESP tool, which we've got. And we're probably going to want the bin file, actually, not the UF2 file. Let's save that one as well. Now, if we go in here, go back one. Do I have ESP tool? Oh, thought I did. All right. Get that installing, and I'm going to grab this USB-C cable. So now I'm going to hold down the boot button whilst I plug this in. And it doesn't look like we're getting any display out. So I'll hold the boot button, turn it on. Have I connected this right? Let me have a close look here. You know what, it's probably the other way around. Probably need to connect it this way. That makes sense. I'm going to need that UART port anyway, and this will power the LCD. So let's turn it off again, plug in that UART connection, hold boot, turn it on. There we go. So we've got a little red LED there showing that it's on. I'll just bring that up closer to the camera for you so you can see that red LED. And I can see that the backlight is on. I think you might be able to just see that as well there. So the display is getting power. Now if we have a look at D message. Oh my God, I cannot type today. Yep, we can see our converter. And let's go back to our basic commands. So ESP tool is there. So we'll go, where did that connect? TTY USB 0. ESP tool port dev TTY USB 0, right, flash, yep, flash mode, let's go DIO. Now let me just have a look. This is for the P4. All right, so we'll go QIO then. Flash size 32 meg 0x0, and we'll want to go for this bin file. What's this saying? What did I get wrong? I'll quickly have a look and get back to you. One tick. All right. It looks like I was just overcomplicating things slightly, so I just did write flash with the Z, so it flashes it and write it from 0. And it looks like this is putting it through, so it should be everything that we need. Let's see if we get a REPL prompt when we connect to it afterwards. Alrighty, after a little bit of digging, I figured using PuTTY is going to be the hard way. And I also found there's two different ports to use. So the way this CircuitPython binary works is you flash it using the UART port, but then you need to change it across to the OTG port. So we'll see, if we go to our desktop, we'll grab our desktop camera as well. Got Thonny open here. If we unplug it from here and move it across to here, there we go. So we can see we've got flash drive that's appeared. And if we just hit stop to refresh, Adafruit CircuitPython is running there. So that is actually working, which is quite excellent. Now what I want to do is I want to go back to my GitHub repos, not go to the board taxonomies though. I've got another one that I've been working on. It's a bit of a work in progress here, but it's essentially going to be a universal benchmark. I'm really crap at coding, so there's a lot of LLM helping me here, but I've already used it once, and you can see under our results, we've got examples and we've got the schema defined there, but we've got some RP2040 and RP2350 results here. So I'm using these to create a score, and I'm creating tools to visualize the scores and to rank them as well. What we want to do for now though is just go and grab the code that I've got that I used before. What the hell, that was the wrong button. This one. So this is using MicroPython or CircuitPython using ULab in place of NumPy, because that doesn't exist in MicroPython, but I believe CircuitPython has it. So let's copy all of that, paste it all in here, see what breaks. No module named machine. All right, where am I using machine? Let's just delete stuff and run it. Benchmark failed. Machine.frequency. All right, let's quickly look. All right, there we go. I did consider moving that upper limit higher than 256. I tried 512, but then I realized how long that would take, given the pause that 256 by 256 took. So now it's going to do a couple of warm-up runs, and then we're going to be doing 10 iterations of 256 by 256 multiplication to see what sort of score it gets. It's not actually going as fast as I thought it would for the amount of power that this processor has, but the ESP-IDF actually uses something called ESP-NewLib or ESP-IDF NewLib. And this is a library, a C library that Espressif released that actually uses the hardware implementation of these multiplications, of the matrix instructions or vector instructions that these chips have. I don't know if CircuitPython is compiled against that. So that might be some of the reason for the slowness. We should still get a huge amount of power out of this regardless, and we'll see at the end. Interestingly, it's 360 megahertz, not 400 megahertz, and that is mentioned in the documentation as well. That's the way it's clocked for a certain reason I don't recall off the top of my head. So we'll let this run and we'll see how it goes. In the meantime, we do also have our IDF download completed. So if we go back to the documentation here and have a look at what we're going to need, set up the tools. So clone IDF, go into it, and we want to install tools for that. So we're going to want to install the tools for the P4. So let's go ESP-IDF install, what option do we have? .fish? No, ESP32 P4. So that's going to download what we need for the P4 now. We'll let that keep going for a tick and have a look at what Thonny's doing. That's ticking through quite nicely. And, oh, that's definitely getting warm. Let's stick a thermal camera. Do I have a thermal camera here still? Yes, there we go. Stick a little thermal camera in front of it and see how hot it's getting. Alrighty, what's that look like? Wait for it to auto adjust. Oh yeah, sitting about 45 degrees. So that's not all too bad. Hang on, let's fix the autofocus, there we go. About 45 degrees. So I recommend maybe adding some cooling to it, but that is not bad at all. We're up to 5 cycles. How is our GitHub going? All right, we'll come back to this in a tick once we've got everything we need, all the cycles are completed. All right, we're on the last one now. So if we quickly go back and have a look, we can see at the RP2040, we had a maximum inference milliseconds, or actually what's probably better is average inference milliseconds of 4.81 seconds. That was giving us a throughput FPS of 0.208. Now, I can't recall off the top of my head with this code how directly they're going to compare, because it's got to do with the size of the multiplier as well, but I think I divided it back out in the code. I might have to check. This only uses 130K of memory, and then down here we 288K of memory, and we got nearly 3 times that, which was quite impressive. So now, actually, did it properly dump it to here? No, I thought it might actually manage to output it, but it doesn't. So, read-only file system, that's why. So, 28 seconds maximum, 256, there we go, minimum is 256, 330 megahertz, 0.03 FPS. All right, so this definitely isn't comparing them very well. We might have to multiply that out somehow, but I do have some comparison code I haven't finished. All right, my code's busted. So the last thing then is, we just got all of that. So let's export those things that we need, and we'll go idf.py menu config. Ooh, what are we missing? Oh yeah, all right, that makes sense. Examples, P4 Eval Board, examples, and the Brooksia phone. Run that again. This is all in the documentation over here, I believe, yep. Menu config, component, board support package. Example configuration, enable SD card, so we'll have to do that. I've already converted the file that I want. And then we'll flash it. It's got a bit of compiling to do, let's give it a tick. Alrighty, so example configurations, enable SD card, and we want to go to component config, board support package. Wow, there's a lot in here. Board support package, that one. Huh. Okay, so that's all right. Board support package. Why am I even going there? Why is the example say run menu config and go to that? Yep. To use that, go to menu config example, experience video. Yep. All right. So I think this documentation might be a bit crap. If we save that configuration and just do idf.py make. I don't know why it said we had to go into here. I meant build. My bad. There we go. That's doing a whole pile of things. All right, so now over here, we'll want to unplug it from there. Oh, come on, get out of that. Hold boot, plug it back in there, so it's in flashing mode. And we'll want to go ESP, I mean, there is idf.py, there is, it tells you what to do on there, but I don't think we need to. We can just go -p dev tty USB 0 flash, because we're in the IDF tool chainer. It knows what to do with what we've got. Otherwise, that is the code there to do it manually. So you can see what it's doing is using a 0.5 meg baud rate, default reset, hard reset after write flash, DIO, flash frequency 80 meg, flashlight 16. It's going to write a bootloader at 0x. It's not running anything at 0x0 first. So I'm wondering if what we have already written to it might need to be overwritten for this to actually work, considering it doesn't have the normal bootloader on anymore. But we'll see what happens when it resets. So that is flashing now. Turn this over carefully because it is going to do its own hard reset. Make sure we can see the screen, which is currently just a slowly moving view of all my containers up there whilst this finishes writing. All right, that has hard reset. Not seeing anything on the screen yet. What's the story, Morning Glory? I'm gonna just unplug this and plug it into the normal power in. And I'm assuming that's because of the bootloader. So let me just have a quick look. I'm going to see what we need to do to put that bootloader back at 0x0. Alrighty, so what we can see here is it is actually booting up. I'm just going to reset it so you can see that again. If I hit reset, it actually goes through the full boot up, so everything is there like we need, but it starts trying to mount the SD card. Where we go, so SD eMMC there. And that's because I haven't actually put the SD card in it yet, so let's do that. You got to remember, this isn't a normal computer. If it's expected to do something, it expects its hardware to be there. There is, you know, it is an ELF file, it is a RISC-V core, but if it's programmed to say that there's going to be something connected that it can use and it's not there, it's going to hard fail. It's not going to give you a command prompt or anything like that unless you code one in yourself, which this certainly has not. So let's reset again. Watch what it says it's doing. There we go, that's looking quite good. It's even done the Wi-Fi in it and everything like that. Let's turn it over and see what we've got. Look at that beautiful interface. So if I can get it, here we go. So you can actually see it properly. It's a bit hard for me to turn off all of these overhead lights, but that's a pretty good view there. So what have we got? Wow, this is actually very easy to use. It is very Android-y. So can I swipe up, yeah, to close it? All right, what's this square line? Oh, all right. Oh, so you've got a little phone call thing, so I can call some random person. There's quite a nice user interface it's got built in here. Is that actually going to play something? I don't have speakers hooked up because I don't have any speakers. Close that. Fully functioning calculator. Camera. Wow, well, there's heaps of stuff going on then. The camera app is crashing. Don't know why. I'll try resetting the camera. That is almost definitely connected the right way. Oh, it's not actually. Let's reset that. The FPC for the camera was not connected properly and is very squirrely. Is that going to work now? Yep, there you go. So we've got a bit of rolling shutter, but you can see there's the camera recording above. Probably just have to change the frequency. So you've got a little user interface, pedestrian detection, face detection, normal detection. It can even take photos. So if we close out of this camera, don't know how to get to that. All right, 2F48 is always a good game. That's cool. Let's see if the video player works. There is my file there. It appears to be failing in the buffering. That's a shame. This actually works though. Let's give you a bit of a close-up view. Hang on, my cable is pinched there. Of what I'm seeing. Well, it's very shiny and reflective, but that should give you a fair bit of an idea of this interface that it's got going on. So it yeah, is if I... Oh, all right, there you can see that. That is really, really cool. That is a really good example of what this thing can do. There is nothing on those other pages. Oh, I don't know if the Wi-Fi actually works. Turn that down. How do I go back? So I don't actually know what I'm doing too well, as I'm sure you can tell. Oh, it's got multitasking. And it's showing a battery percentage that doesn't exist. So that, all in all, is actually very impressive in my books. I'm quite thrilled with this. So for the documentation, I'm going to give it a 3 for documentation support. It is a development board or an evaluation board. For the software, I'm going to give the software a 4. There's not a huge amount, but we've got CircuitPython going and we got the example code going, and it works very, very well. It's quite complex. For performance and reliability, I would say these things are rock solid. It's what they're meant to be. So performance and reliability is going to be a 5 out of 5. Everything is pretty much working as it was meant to, and any faults have been either in the documentation or in my own understanding. That's because you really do need to know what you're doing with these, and I'm just broaching the surface of it, As far as accessories and power and whatnot go, so if we have a look at this, it does come with all of the accessories in this kit. It uses standard 2.45mm headers on there. It's it's got an ESP32 C6 for the Wi-Fi, which is easy to flash. You've also got these headers there for it. Supports a standard connector for the battery. Both types of USB ports, standard MIPI CSI and DSI, normal Ethernet interface, a nice little spring-loaded SD card. It is stock standard, and it's got a whole pile of options. It doesn't appear to have PoE support in any way, shape, or form. Doesn't have a case, but it does have these nice mounting holes. So for this as a kit, I'd say it is very widely compatible. No M2, you don't need it with something like this. No powerful 3D GPU, again, not necessary with something like this. But it does have, you know, the VPU or the ISP with the hardware encoding. It's got the camera and screen support, and the examples show that they do work perfectly. I'm curious if you can reverse power it through that screen. No. Does look like a normal power port, but it just might not be negotiating enough current, might not have the pull down resistors there. So all in all, I think this is a really, really capable product. I'm quite happy with it. As far as its intended use, it is meant for, like most ESP32 or Espressif products, HMI, human machine interfaces, very, very good at that. You can see that they are branching out a bit more now. So it's not just all Wi-Fi and HMI. They're starting to get cameras more involved. They're building out more fuller example code for it, like this Brooksia phone app. So I'd say as far as the HMI goes, it's very, very good. It could, you know, it would be nice if it came with a case, but for example, code is not bad at all. The touch was really responsive. It's me trying to hold it right that was making it a little bit difficult. I think this, for what it is a 4 out of 5. All they could have really improved on is the documentation. That would have probably made it a 5 out of 5. I think that MCU itself is a 5 out of 5. It is a very, very capable processor. And if we have a look at the evolution of these, yeah, I was trying to cheat a little bit there. I didn't actually even end up logging in. There was a DF Robot page that showed kind of the evolution of what Espressif are doing. So the fact they're doing dual-core RISC-V processors with extensive HMI support, advanced security built-in, AI extensions, everything like that is really amazing. They're making great stuff. That's why we're seeing them more widely adopted, and this is a fantastic example of it. So let me know what you think. I might put a poll below, a yes, no, of whether or not, or a link to it on Reddit, whether or not I should get things like this in stock if you want to buy them, if you'd enjoy them. I would love all of your feedback and comments about these. Anything you want me to test out, any thoughts you have on my SBC tier list that I'm putting together somewhere back over here. This will get a nice A. This is an A grade product. And you've got to remember what I'm putting in the tier list here is this whole product, not just the SoC or MCU. So last week we had a look at the Waveshare RP2350 plus 4 meg. That got an S tier. Everything worked flawlessly and the documentation was fantastic. This was very close, just documentation's a little bit rough. Comprehensive, but rough. Now, if we start looking at some other examples, if we do get other variations of this in, they will have their own documentation, and that might make it into an S tier run. I know I'm expecting a comment from you. So thank you all for coming along. I'd love it if you like this stuff to go check out my shop. Have a look at my tools and accessories, because I do stock even Peinzel soldering irons and stuff like that. I've got all sorts of modules if you're into electronic stuff, which you can hook up to these with GPIOs. If you want componentry for this sort of stuff, I do have cameras and displays and everything like that, and I'm constantly getting more in. And I do have other dev boards and SBCs and things like that that you can play with if you want your own. So I hope you're doing well. Hope you have a great weekend, and I'll see you folks next time round. Cheers.